led off by Ramin of Ethernovia. Um, Ramin has told us some about his company. Effectively, as I understand it, it solves quite a few problems all at once. It's basically a new paradigm for wiring vehicles, smart vehicles, to partly resolve the problem of huge amounts of data that has to be transferred internally, even within vehicles, as well as to resolve the multiple duplicative and non-interoperative systems of circuits within vehicles. So I don't know if I did it justice to your concept, Ramin, but why don't you go ahead and make your presentation?
But first, I would love to have Dan hop on there and say a few words as well.
Oh, I'm sorry, Dan, got to do the intro?
Yeah, well, and Nick had asked me to jump on to give the quick intro, and I'll keep it simple. I think, Howard, you hit it. Ramin and his team, we first connected with them and made the introduction here for the Doon Insights Day today. We connected with them, gosh, back in sometime this summer, I think, and had a great chance to meet with Ramin and I think his colleagues Roy and Chris, and we're really impressed with both the company. The team they put together is one of the more impressive ones, especially in sort of the startup world and companies that we're often taking a look at, and then obviously their vision and technology. Yeah, I think, Howard, you hit it at a high level. I think neither of us could probably do it justice to what Ramin's developed, but they're effectively virtualizing the communications and the electrical architecture within the vehicle, and they've got these chips that improve the performance and efficiency as it relates to how all the communication protocols on the vehicle, and really important. Just because there's, if you look at the design and architecture of vehicles today, it's kind of a brute force approach and really kind of ugly and limited. And as you're adding more and more sensors, more connectivity, vehicles are producing more data. What they've kind of put together is really needed both today and then thinking, forward thinking. So, we think this is a pretty compelling opportunity and one of those technologies that is really needed to move into all these mega trends: electrification, connectivity, autonomy, and we think they've got a really interesting team with some really strong experience both on kind of the big company side across auto, semiconductor, the network architecture, and they've had some success taking companies public and being part of really high growth blue chip companies. So with that, I'll maybe hand it back off to Howard or Ramin, and I think everyone's going to enjoy hearing more about what they're building and all the traction they have.
No, please go ahead, Ramin.
Yeah, absolutely. Very nice to meet you all, to meet all the audience. So Ramin Shirani, I've been in the industry for about 30 years, a lot of Ethernet background, have done multiple companies, taken an IPO. And we started Ethernovia about 4 years ago, and have grown it, have our first product coming out shortly here. And we're about virtualizing vehicle communication. So with that said, and the kind words from the other audience, let me just go ahead and share my screen. And then from a time check, I have what? I have till 2:20?
Yep, that's right. We're around 2:20.
Okay, let's dive in. Okay. So Ethernovia, really Ethernovia is about virtualizing vehicle communication. If you look at the car today, the car obviously has significant intelligence and ever-growing intelligence with what we're seeing with the trends in electrification and autonomy. The cars of today, obviously have the brains of the car from the likes of Intel, NVIDIA, a lot of sensors, right? We all see kind of going from level 2 to level 3 to higher levels of autonomy, above and beyond just cameras and, other sensors. You have LiDARs, you have radars. And the connection between the brains of the car and the sensors is through the network of the car. And what you can imagine as a contrast to the body would be on the nervous system of the car. Really, this nervous system of the network of the car has evolved over the past few decades into a very complex, non-homogeneous set of wires and networks at the physical layer and at the protocol layer. And it's really at a point where for the next generation vehicles and for scalability of next generation vehicles, there's a new networking required and new connectivity required, which provides the simplicity, the transparency, the efficiency, the scalability, the connectedness, and the intelligence for the next generation vehicles. Really, the aggregate of these networks from the old-fashioned CAN, LIN, FlexRay, MOST, some Ethernet, and the evolution over the number of years from megabits to now gigabits is lending itself to a new architecture, which is scalable for the next generation vehicles, from ADAS to sensors and cameras to other aspects of the future generation cars. So if you look at, again, this picture is worth 1,000 words. If you look at the cars from 1990s to today to tomorrow, it's inevitable that the number of sensors, displays, and the connection within the vehicle, right, the connection speed within the vehicle, and the connectivity now with over-the-air updates to the cloud is ever growing. I mean, today's car have anywhere from tens of sensors to multiple cameras to displays to, depending on the model car, 4G or LTE connectivity, and aggregate bandwidth inside the car of multiple gigabits. The cars of the future obviously will have, multiple more sensors, cameras, displays on the path to be 5G connectedness to the cloud for over-the-air update, which is an important part of future vehicles, especially for software-defined vehicles, and multi 10 gig worth of traffic. And Ethernovia enables the automotive evolution by creating the next generation networks for what we call virtualizing connectivity and the connectedness required for next generation vehicles. The picture is worth, again, 1,000 words. And if you look at the left-hand car here, as we call today's problem, to the right-hand car, and these are not stock photos. We drew these from scratch by working with various OEMs and looking at their wiring diagrams. What you see an aggregate of different networks. The different colors of yellow, green, red, indicate CAN, LIN, FlexRay, LVDS, some Ethernet. And the black dots are ECUs, electronic control units. A car may have, a mid-class car may have anywhere from 60 to 70 ECUs, and a higher end class, let's say a Mercedes S-Class car, may have as many as 150 ECUs. What you can see is the evolution of network of the car has created a mess of wiring harness. The wiring harness is the third heaviest component, the third costliest component. And truly in its existing form, it's a bottleneck for manufacturing the car. If you go to some of the plants like BMW and you look at how cars are made, almost everything is robotic. When you get to the point where the wiring harness is done, for the most part, it's manual labor. So half of the labor, manual labor, right, not automated labor, half of the manual labor of making a car for certain OEMs has to do with the wiring harness, right? It's not only putting the wiring harness, but testing and certifying them. And then from a reliability perspective, once the car leaves the showroom, wiring harness is one of the major reliability concerns during the warranty period. So really not a scalable, proposition moving forward. Again, going down the list here, the process complexity, as you see with different levels of ADAS moving from, level 2 to level 3 to hopefully, higher levels over the next decade, you see significant process complexity, which requires more brains in the car, requires more CPU horsepower in the car. and the connection to these various sensors, in particular to higher speed and higher resolution cameras, produces a significant amount of data in the car that would require process complexity, which current ECUs shown in the black dots have a hard time handling, because you can't continue adding ECUs for every function. The most important, if I would say, would be the software fragmentation. A car like shown in the left hand above picture has as many as 200 independent software suppliers per vehicle. No wonder it takes, for some existing OEMs, it takes anywhere from 5 to 7 years from concept to getting a car out the show floor. So really, kind of our vision a few years ago and now pretty much industry vision is a seamless, holistic system of removing this complexity. What you see here on the right-hand side is an example. This is not necessarily the architecture that has to be in place. Could be zonal, could be central, could be a combination of both. But really kind of moving from the left to the right, you would see zonal aggregation points where the data is transferred over rather high-speed networking over single pair cable of multi-gig. The zonal points would have compute abilities in them, so that a lot of the functions which otherwise had to be done with disaggregated ECUs would now be done in the zonal points. And then perhaps in this particular example, the processing, then final processing is done in the central zonal point. So this again, as an example, what's very important is to support the legacy, but the support of legacy of CAN and LIN is important because we don't necessarily think they're going to go away anytime soon. And the transition of the car to entirely an Ethernet system, even though it's a novel concept, we think that's going to take a very long time. So really going to higher speed Ethernet as the backbone with support of legacy is, to us, is what's going to happen in the future. Now, virtualized compute, right? Instead of having 70 to 150 ECUs, there's no reason for your applications not to run on these zonal aggregation points with certain level of compute. And the final being done at the, potentially in this example as the central ECU or the central brains of the car. And then software fragmentation, right? We all know it's almost impossible for the car to scale. If the current cars require 200 independent software, then you need to have a unified software, which, as you may know, and it's publicly announced, many major OEMs are moving toward unifying their software and hardware and moving to their own development of their own operating system and the associated software. So really what Ethernovia does at the high level, we virtualize Ethernet connectivity, we create the connectedness in the mobile data center of the future, which is nothing but core. You see in this diagram the likes of Intel, Mobileye, NVIDIA for the brains of the car, the accelerators being the likes of Mellanox and Umbrella, and the networking kind of moving forward, both in acceleration and bringing the networking piece together is what is our charter at Ethernovia. What the cloud computing did for internet, Ethernovia is doing for the car. Again, without going through line by line, but the current solutions have disaggregated ECUs, disconnected data, separate networks, certainly limited bandwidth, and isolated ECUs, and no hardware offload for relieving the load on the CPUs. And what we, in a set of products and solutions, which is at the chip level and at the software level, we provide at Ethernovia the consolidated high performance and unified data, the network which is unified and scalable, and the modular and extensible and upgradable software which is also scalable. So again, this is an example of different levels of driver assist. And this diagram kind of shows on the right-hand side, as you can see with the color, associated color, going from level 1 to level 5, and the potential associated aggregate bandwidth inside the car. And you can see the ever-growing need for the bandwidth going from a few gigabits all the way to potentially 256 gigabit as aggregate bandwidth of networking inside the car. And you see all the different features that the car have today and the cars of the future, from lane departure warning to lane keep assist to levels of autonomy to all the smartness that today's car and the future cars will have. And effectively, the ever-growing bandwidth need itself is driving a lot of the need for the network scalability and virtualizing vehicle communication. So in summary, yes.
Can I ask you a quick question while at this point? So your reimagining of the whole network of the vehicle seems like it would potentially revolutionize a lot of other things inside the vehicle, right? I mean, so a lot of other parts, systems, software would have to keep up with you, I assume. So what would have to also happen in order for a OEM to implement your system? What other systems would have to be upgraded?
Right. So even though we show the vision of what an ultimate car with this kind of upgrade would look like, we all know in reality in the car manufacturing today, the progress would potentially be incremental, right? It wouldn't necessarily be revolutionary, but it would be a step at a time. And what we've done is we've created all the necessary hooks at the hardware level and at the software level for incremental approaches for some other OEMs and more revolutionary approaches for some other OEMs who are willing to go there. So, for example, I mean, what's a prime example of that? Support of legacy networks is fundamental, as I showed you in a few, diagrams before. As you can see here, the support of the legacy network on the right-hand side, with the yellow, green, still and the blue still existing in the right-hand vehicle, and the connectedness of the backbone of the vehicle with the legacy, which we think is going to be in place for the next decade. LIN and CAN are plenty cost effective, and we don't think they're not going to necessarily go away anytime soon. So really that incremental step is what we're proposing. And for certain other OEMs who are more revolutionary, they're starting with a clean sheet of paper, especially with a lot of their electric vehicles, where they start with their own software development, their own hardware development, and to the extent possible, push toward an architecture for the 25 to 27 timeframe with a lot of these innovations built in. But we support both.
Okay, thank you.
Let me quickly jump to the last slide. So really, Ethernovia is about a breakthrough scalable series of products from vehicle edge to core. We do develop the integrated circuit at the physical layer and at the switching layer and at the smartness at the offload layer. We create a seamless holistic system that removes the complexity. We virtualize connectivity by creating the network simplicity. We virtualize the compute through seamless running of the applications over the next generation, hardware and compute locations. And we virtualize software from sensor to cloud with the overall solution that we provide. Thank you very much, and I open it up to any questions.
Okay, great. So we're almost out of time here, but do we have any questions from the audience? We'll still have a chance to ask Ramin questions when he comes to Bonny Doon, but maybe one question, if anybody? Well, I think looks like you've covered everything, Ramin.
Okay, I appreciate that. Thank you very much. And look forward to seeing you guys in Bonny.
Okay, we'll see you in a week.